Hello, you are welcome to my YouTube channel, 5E Virtual Geospatial. Today, this lecture series, we are going to look at the band combination and the purpose of band combination, specifically in Landsat image. Though you can do a lot of combination on any satellite image that is medium resolution or low resolution, you can do band combination to allow proper rendering of the image or proper rendering of the landscape that you are trying to monitor. Satellite images have become the richest sources of images in this generation because satellite are hovering the Earth's surface on a number of days. Today, we have a Landsat 8 that generates more than 500 uh, scenes per day and huge data resource for the GIS communities and remote sensing communities in the world. And the data is available free for public use to do for research purposes and for a number of applications in landscape management, climate change modeling, and a whole lot of environmental applications. Uh, if you look at most of the Landsat images, Sentinel images, spot images, and a lot of medium resolution images, they have a lot of bands because of the scanners that are mapping the Earth surface from the images from the satellite. So Landsat 7, for instance, that has enhanced thematic mapper, has 8 bands. Band 1 is visible blue, which is in the range of 0.45 to 0.52 micrometer and has a resolution of 30 meter. And then band 2 is in the visible green, which is 0.452 to 0.60 micrometer. And then visible red is from 0.63 to 0.69 micrometer. They are all in the visible portion of the electromagnetic spectrum. And we have the near infrared, which is in band 4. Band 5 is also near infrared. Band 6 is thermal infrared, which measures the temperature of the surface temperature of the land surface temperature of the surface. And then we have band 7, which is mid-infrared, and then band 8, which is panchromatic, which is black and white. The panchromatic is actually 15-meter resolution in the spatial resolution component part of the electromagnetic spectrum. Now we know that all these have specific applications, and in the visible portion, there are a number of things, there are a number of spectral signature that is better captured at band 1 within the range of 0.45 to 0.52. For instance, water bodies is better captured in the blue portion of the electromagnetic spectrum. And then when we talk about vegetation indices, vegetation nitrogen-rich component or chlorophyll of the vegetation, visible green and visible red are better able to capture the signature properly. And then the Landsat 8 also have different bands, has 11 bands, while Landsat 7 has Landsat 7 has Landsat 7 has a enhanced thematic mapper, but Landsat 8 has a operational land imager and thermal infrared sensor. That is why it's able to capture in 11 bands of the electromagnetic spectrum. Band 1 is also 0.433 to 0.45 micrometer. Band 2 visible blue, band 3 visible green, band 4 visible red, band 5 near infrared, shortwave infrared. Band 6 are the new additions to band Landsat 8, which is an advancement or improvement over the previous satellite in operation. So Landsat 8 was actually launched in 2013 and is still in operational. And then we have band 8, which is panchromatic. We have band 9 Cyrus, we have band 10 and band 11, which are long wavelength infrared, which is about 100 meter in the term of spatial resolution. So these images have different applications. They have different, when we combine one or two of these bands together, it presents a better rendition, better signature identification, signature description of the landscape when you combine through 2 or 3 images, 3 bands, because they are strong in different portions of the electromagnetic spectrum. So when we want to do mapping, we want to map coastal area or water bodies like lakes, like the sea, lagoon, estuaries, and coastal environment. The band 1 should be part of our data set that we want to use. We want to distinguish between the soil, bare soil, and vegetation, or want to differentiate between different types of vegetation like rain-fed forest and rainforest. Want to differentiate it from mangrove, then it is better you use blue. And by the time you combine blue band with green band, and then it gives us a better presentation of the area, of the landscape you want to measure, want to map, or want to look at. So band 4, which is the red band, we are looking at the band 8, which is a Landsat 8, which has 11 bands. So we have the panchromatic also, and sometimes we want to use the high spatial resolution of panchromatic to combine with the multispectral rendition of the band 1 and band 2. So we can do a combination of these images, and we call it pan sharpened. We can use panchromatic to sharpen the multispectral images we have. This is for another time, but today we just want to concentrate on why do we need to combine bands and how do we achieve this in using uh, QGIS. We are going to use QGIS because it is free and it's open source software. You are not going to violate any copyright license because it is in the Creative Commons domain of the intellectual properties. So we have different band combinations available in images. So when we have natural color, we can combine band 4, band 3, and band 2 for natural color, and look at band 3, band 4, band 3, and band 2 give us the natural color 4, 3, 2. 4, 3, 2 will give us the natural color presentation of the environment as it appear when we are taking a normal photograph of the area. So by the time you combine band 4, band 3, band 2, it gives you natural color rendition. But if you want to do a first color composite or color infrared, which will bring out the vegetation component of the landscape properly, so we could be able to discriminate between different vegetation types. For instance, you may want to discriminate between cocoa plantation and kola nut, or the cocoa plantation and palm, or banana, or citrus. You can use a color combination that has something like that is heavy in the infrared, that's heavy in the red portion of the electromagnetic spectrum and the infrared portion of the electromagnetic spectrum. The popular used ones is band 5, band 3, band 4, and band 3, which is band 5, 4, and 3, which is near infrared, red, and green portion of the electromagnetic spectrum, 5, 4, 3. So it depends on what we are looking at. And then you can also do vegetation indices. Vegetation indices is a image 1 plus image 2 divided by image 1 minus image 2, which will give us a normalized difference vegetation index. And we have different use of this. The natural color is will help us to see, will replicate close to what human eye can see. While earthy vegetation is green, unearthy flora is brown, urban features appear white and gray, and water is dark blue or black. So when we use a natural color composite, you see what your normal eye will see. If you are looking from the plane or you are looking from the aircraft, you are able to see what your normal human eye will see. By the time you combine band 4, 3, 2, you must be in that order. The red band will be up, the green band will be below, and blue band will be at the bottom. And you are going to combine it together. But color infrared, like first color composite, FCC, it will mean you are emphasizing the infrared portion. So near infrared portion is the 5, red, and the green, because the chlorophyll component of the vegetation reflect higher in the near infrared. And this is why it is, though the vegetation, the image will appear reddish, we have red combination, we have heavy red combination, but it will help you to discriminate between images of between vegetation of different types. You can even differentiate between species of different vegetation if you use that. So we are going to quickly go into how we can achieve this in the QGIS environment. And this vegetation index, we have the normalized different vegetation index, which is we are going to use the image. We are going to do map image algebra when we combine image 1 plus image 2 divided by the result will be divided by image 1 minus image 2, and that is for another another time. So, but let's quickly go to what we have, how we achieve this in the GIS, in the QGIS environment. So in the QGIS environment, we have first thing we need to do is to open the images, because we are not going to how we download images from the site of the Landsat, because that one, if you want to see that one, you can go to my previous videos so that you can understand how you can actually download or you can source your images. But we are going to use some of the images we have in our system, and the first thing we need to do, we have image, one of the Landsat image here that we have band 2, band 4, band 3, and band 4. So we are going to open these 3 images. When you open these 3 images you had, if you are looking for how you can open images, you can check some of my video in the past, and then you can have some of our previous videos. And if you want, I implore you to subscribe to my channel so that when another another video comes out, you'll be notified. Now, these are the images. We have the band 1, and you have band 4, band 3, and band 2. So if you want to do color composite of this, we can do band 4, band 4, band 3, and band 2. And we said in my previous video, one of our previous lecture series, we looked at how you use SCP plugin, how you can download SCP plugin I quickly go into it. If you want to get SCP plugin, which is the plugin, or we can call it the sub-program, subroutine to use to process your images and which a band combination is, the first thing is to go to the plugins, manage and install plugins. And when you click on manage and install plugins, but you must make sure that you have internet on your system, so you can search for SCP. SCP is a semi-automatic classification plugin. So, but because I've already downloaded, you can and I've downloaded and installed. That is why it is available like this. But if you don't have it, you need to install the SCP. After that, once you have your SCP, you can now go to band set. Under the band set, it will take you to this environment, and then you can click on this tool to bring in what you have opened on your display window here. So when you click here, you see that it has brought it here. Band 2, band 3, and band 4. So I'm going to bring it here. You select, and then you add it here. You add it to this. So that means these are the band set you want to look at. You use this plus button to bring it from this environment to this environment. And now you have this band, you have band 2, band 3, band 4. If you want to change the combination, that is what we want to do is 4, 3, 2. So you can move this. You can either move this one up, and then you move band 3 up. Now we have band 4, band 3, and band 2. So once we have this, then the next thing you need to do is that you have to look at the bottom here, create virtual raster or band set. Yes, we want to create it. Create raster band set, stack images, build band overview. We don't need that. Band calculation expression, well, let's put it. Then you come to this and you click on run. Once you click on run, it will ask you where do you want to save the new band. So you are going to select, you need to select a folder where you want the data to be clicked. I'm going to click choose dev as the place we want to put under help. Let me click Ethiopia, and then choose dev. Let me please choose dev. So select folder. You are going to click on select folder. Once you say select folder, it will automatically continue to run. So while it's running, you see it here on the display window. It's writing it. You can see now that this image is better. It presents the water body in a very good presentation. You can see the area. You can see this is different from each of the images that we have before. Before, what we have are several types of these are the one we have. This band 4 alone. This band 4 alone. This band 3 alone, and this is band 2 alone. But this one now, we have combined the images together, and you can see that this image shows this is a true color composite or natural color composite, because the water appear as blue, and then you can see the vegetation appear like this. We are going to do first color composite now, which is going to be that I want to do the other way around. Instead of doing 4, 3, 2, we want to do 2, 3, 4. That means we want to emphasize the blue portion of the electromagnetic spectrum, and then you go to the same tool, band set, and then let's see what we have in this time around. Instead of having 432, we are going to move 2 up. We are going to move 2 up. We are going to move 2 up. Now we now have 3 also will go up. Yep. Yes, 3. Okay, let's move 2 down. So we now have, wow, sorry. Now we have 2, 3, 4. 2, 3, 4, we run the same thing, and then we put it in the same place, and this time around we have put it in ChooseDev, and that ChooseDev, you select the folder. So, and immediately it will, if you go to your QGIS display window, it will run this. It has finished, and you can see the image we have with combining the 3, 2, 4, 2, 3, 4. This is the new image we now have. Zoom to layer. You can see this is different. This one is first color composite, where we use 2, 3, 4. But the one that just true color is this. True color is true color is this. The true color is this. The first color is this. This first color, this true color. So this is how you can combine images you want to map. You can see that this a combination of 3 colors is far better and better appreciated. The landscape is better understood than where you use any of the component or composite image. Thank you for listening to this lecture. I implore you to subscribe to my channel so that once another video comes out, you'll be notified. Thank you for watching. Bye.